We're picking up today with our sequence on philosophy of science with a conversation about what really distinguishes science from pseudoscience. You know, things that may appear like science, but really aren't and maybe shouldn't be considered with the same sort of legitimacy, for example. And we're going to learn the perspective on this from different philosophers, so stick around. You're listening to Why This Universe, a podcast where we break down the biggest ideas in physics. I'm Shalma Wegsman.
And I'm Dan Hooper.
Today we're talking about how we can exactly tell science from pseudoscience. In philosophy, we call this the demarcation problem. So to start off, of course we need to talk about how we define science to begin with. And there are two ways to do this. If you were to ask me, for example, what is science? The first thing I would say is that science is a way of understanding the world through hypothesizing, experimenting, collecting, and then interpreting data.
So this is what I would call an epistemological definition. So epistemology being the kind of philosophy that asks questions of how we know whether things are true or not. But there's also people who would say, well, I know what science is. It's things like physics and chemistry and biology and maybe the social sciences, things like this. So there are definitely definitions about like the content of the stuff that makes it science. So this, instead of being epistemological in its definition, it's ontological. Ontology being the kinds of science that have to do with what kinds of things are out there in the world.
So the epistemological definition of science is about the process, the scientific method. And the ontological definition is about the content. What is it that science is interested in? Now, off the bat, this is already a bit fuzzy. Like, is every discipline that looks at the world ontologically a science?
I gave a talk, 5 years ago or something at a humanities festival. And I got into a conversation with somebody about the difference between the sciences and the humanities. I thought it was really interesting. I raised the question, like, why isn't history considered a social science? It was explained to me that history isn't a science because they don't do experiments, right? Like, if you like set up different groups of people and different circumstances and saw what happened, then you'd be doing sociology.
But that doesn't really make sense because there are observational astronomers who don't do experiments, but we definitely consider them to be doing science.
Yeah, exactly. And so by the definition that this humanities professor, this historian was giving, I'm mostly not doing science either. So even among like real practitioners of modern, science or humanities or whatever, like have some fuzziness about what is and isn't science. It turns out to be really hard to define. And, it's not clear that there's even a right answer necessarily, but I think you can learn a lot about what science is by just asking the question and pondering it deeply.
And then there's also the element, right, where science is kind of an institution in the sense that the process goes beyond just like any individual kind of doing a little experiment, but also like if you want to be a part of science, the institution, you have to be peer reviewed and put out a paper that follows certain guidelines and things like that.
Yeah, but I think that's more historical in nature. Like, nobody thinks that Isaac Newton wasn't doing science, but he never, went through peer review.
Yeah, I guess I just bring it up because of, is a kid who's, using a magnifying glass to burn ants in his backyard, doing an experiment?
Poor ants.
Doing science, yeah, poor ants.
Yeah. Okay, good. And probably, but I would argue that if that kid is writing down hypotheses or at least conceiving of hypotheses about what will happen to those ants and really is curious to find out and maybe logs his data and whatever, then he's doing science.
Does he have to log the data, or can that all happen in the mind of a child?
Oh, sure. I mean, I'm not saying it's the most sophisticated example of science, but that sounds like science to me, All right. So the next question is so why might we care about what exactly science is or isn't? And my answer to that is that science has just, in our experience, in our history, been shown to work really well. In other words, going back to one of the definitions of science that is offered often, it's like an idea, means by which humans gain control of their environment. Okay, so whatever we do to gain control of our environment, you might want to call science.
Well, it's interesting that you use the word control and not just, knowledge of.
Yeah. Regardless of what we need to do, when we do science, it definitely gives us the ability to control it.
In other words, even if you're doing science just to learn about the world, that knowledge does give you the ability to manipulate the world and give you certain results.
So you might think it would be rather easy to distinguish when somebody is trying to do science from other things. But this has not always been as straightforward a question as you might guess. And this issue has worried and concerned a lot of different philosophers over history. And philosophers have started to call this around 100 years ago, the demarcation problem.
So now we're going to get into the history of different philosophers of science and what they had to say about the demarcation problem. And we'll start with one by the name of Karl Popper.
Popper was born in 1902, lived until 1994. He's one of the biggest deal philosophers of science of all time. If you know, like, one philosopher of science, is a pretty good chance it's Karl Popper. He's kind of that singular figure. He was born in the city of Vienna, which is now in Austria, but at the time was part of the Austro-Hungarian Empire. And he would be influenced by, and in return would be, influential on a group of philosophers in Vienna at the time called the Vienna Circle. Out of the Vienna Circle came the whole idea of logical positivism, which is one of the most important movements in the history of philosophy of science, and included people like A.J. Ayer and Rudolf Carnap and others. Logical positivism was a very aggressive empiricist movement. So they thought the only knowledge you could have came from observation and logic applied to the data collected from those observations. They thought that there were no other ways to learn really anything other than tautology. So everything you can learn is either just tautological, meaning it's like true by its own definitions combined with a little bit of logic or something, or it's science. Science is it, according to the logical positivists.
Although by that philosophy, theorists would be out of a job, right?
Oh, I mean, theorists are still pondering data. You don't have to be one collecting data, but you can be thinking about data. You're still, if a theorist comes to a conclusion about something, about the world, they've done it using data, even if they didn't collect it personally.
What about mathematicians?
Yeah, so all mathematics is tautological, according to a logical positivist. If you're a mathematician, sorry for the bad news. But they think, I mean, and they had a lot of respect for mathematicians, to be clear. They thought math was important. Some of their members were mathematicians, but they said deep down, even though math is really useful and really hard to do and all these sorts of things, it was fundamentally identifying tautologies, relationships between different ideas.
Which, I mean, maybe that makes sense if you think of math as just being you're defining axioms, you're defining a system and then finding truth based on that. So maybe all the time that you're spending doing math is really just rediscovering the axioms.
Or finding the logical consequences of some set of axioms, right?
Which is what math is,
yeah.
But it is really helpful and it seems to work well with the world too.
Or at least it works well to organize our thoughts, which we can apply to the world or anything else. Yeah.
Yeah, it's developing the practice of logic.
Yes. And I think a lot of logical positivists thought really all math was logic. And other ways of thinking about logic, which is a really deep and rich question. And we could do whole episodes on that in the future. So Karl Popper was in Vienna in this seminal time in the 1920s, while the Vienna Circle was in full force. But in 1937, as World War II ramped up, he fled Europe and moved to New Zealand. And then later, after World War II, he moved to London, where he was on the faculty at the London School of Economics. So back in the Vienna Circle in the 1920s, those people widely held the view that a statement is only meaningful if it could be verified observationally or empirically, at least in principle. Okay. So in some ways, this notion, which was called the verification principle, goes back even further to like classical empiricists like David Hume. And according to people who are logical positivists or even David Hume or something, empiricism is the only way we can learn about the world. Anything else can teach you about ideas or something, but if you want to learn facts about the world, you have to rely on, statements that could be observationally verified, at least, like I said, in principle.
So to the logical positivists, statements like stealing is morally wrong or God exists or doesn't exist, these statements are all meaningless because there's no empirical truth value to them. They can't be proven right or wrong, and so they hold no meaning or value as statements.
These logical positivists argued that pretty much all of the questions that had to do with things like ethics or metaphysics simply don't have any real meaning. These statements were not true or false. They just didn't have any content, and therefore they didn't have any real answer. Declaring something morally right or wrong, for example, is fundamentally a mistake of grammar to this school of philosophers. It's like declaring that blue is the largest color. Those words in that order just don't have any content.
Unless you're talking about wavelength, in which case you're just wrong.
Yes. Okay. But let's say they literally meant it's the largest color without specifying the length of waves or something. Yes, sure.
Okay, what if like blue is the 10th color?
Sure. Equally nonsensical. Good.
Okay.
So to these people, these ideas, these propositions that you could make that were based in metaphysics or ethics or whatever, like these were not wrong or right. They weren't arguing in favor or against them. They were just saying they were not even wrong. Okay. They don't even rise to the level of being, right or wrong because they could never be verified even in principle. So Popper became concerned with the demarcation problem between science and pseudoscience and wasn't fully satisfied with the answer that the logical positivists were putting forward. When he wrote about the issue, he described being concerned at the time with a few specific kinds of ideas out there that were popular in certain circles at the time, and that were being presented as scientific theories of things, but that he was confident were pseudoscientific, but it wasn't super obvious how to draw the line between those theories he thought were scientific and those he thought were pseudoscientific. So here he had in mind things like astrology, okay, which, I imagine most of our listeners think astrology is pseudoscience. I certainly do. But you could find people practicing astrology who would say, well, the way we do astrology is backed by observations. We've looked at the movement of the heavenly bodies, and we've noticed that when these things are in the sky in certain patterns, these certain things happen on Earth. And we have all sorts of verifications. You could find all sorts of people who will tell you that their newspaper horoscope said something would happen, and then it happened. And the logical positivists would look at that and go like, okay, that's they're checking the box on the verification principle. So maybe this is science. Another thing that Popper was worried about were theories of Freudian psychology, which were coming into vogue around this time. And his view is that Freudian psychology, as it was being practiced, was so vague that no matter what happened, no matter what human beings did, you could find an explanation involving the superego and the id and whatever. He thought that you could practice Freudian psychology in a scientific way, but it wasn't being practiced in a scientific way among its practitioners. And then a third example he was concerned about were people who were advocating theories of Marxist history. Okay, so when I talk about Marxist history, I don't mean like moral statements about it would be good if the capitalists were shut down and the, resources were distributed among the workers or something. I'm not talking about that. I'm instead talking about the causal chain of explanations for historical developments that, people who had read and advocated for Marx expected to be found in the world. So, for example, it was claimed among Marxist historians that in highly advanced industrialized societies, certain events would play out and capitalism would be replaced by, something like communism. But then by the 1920s, Popper looked at the world and, well, this wasn't going on in the most advanced industrial societies. Like, he was living in London and like capitalism was thriving there. But in the meantime, the Bolshevik Revolution in Russia, which was not an advanced industrial society, this had played out. And so like the predictions that Marx had made were not conforming to reality. And you might think that this would mean this would be a falsified or a false scientific theory. But yet practitioners of Marxist history weren't changing their ideas. They weren't adapting to this. They weren't responding to the data in the way that he thought practitioners of a scientific movement should be.
Remember, we aren't making judgments on Freudian psychology or Marxist history here, but these were the things that Popper saw happening around him while he was concerned with the demarcation problem, so it's good to know what he was responding to. And what he noticed in these examples was ultimately that it didn't matter if the predictions of the theories played out or not, the practitioners would still remain headstrong in their beliefs. These theories seemed immune to falsification.
So I want to contrast this, and Popper contrasted this with the, Einstein and his theory of general relativity. So Einstein completed his theory in 1915. And Einstein made some very specific predictions for things that would have to be the case if if his theory of general relativity was true. So like in 1919, there was this solar eclipse, and that allowed you to detect or measure the bending of light as it passed by the sun. If it had been bent more, or it had been bent less or not at all, this theory just would have been wrong, and you would have had to have thrown out his theory. And everybody knew that, and Einstein would have accepted it if it had been true, and so on and so forth. And all that played out, and the theory was confirmed, and people like Popper were very impressed by this. They thought this is the way that science is supposed to work. And these other examples, despite all the data coming in principle, doesn't seem to move opinions. It doesn't seem to change what people think about. So Popper wanted to identify some sort of set of criteria that would explain why general relativity is really science, while things like astrology and, the practice of Marxist history or Freudian psychology are instead examples of pseudoscience. Verification alone wasn't able to do this because people studying astrology and Marxist history and Freudian psychology could all point to ways in which their theories had been verified. And he would say they were cherry-picking data to be able to do this. So what Popper offered instead of verification was an answer to the demarcation problem, which relied on falsifiability. Specifically, in order for something to be a scientific proposition, there had to be things that theory said could not happen. If they ever happened, the theory would be falsified. So with Einstein's theory, if light were not deflected at a very specific amount as it traveled by the sun, that theory would be considered false. That's what made it science. So if you wanted to make Freudian psychology a scientific endeavor, you'd have to say things that people would never do under certain circumstances, or similarly with astrology or whatever. To Popper, this is what makes something scientific. And furthermore, a good theory is something that predicts or prohibits as many things as possible. It's the more it prohibits, the stronger and more scientific that theory is. Consider like a conservation law, like the conservation of energy or something. That tells you that in every single circumstance where you have a closed environment or something like this, you will have the same amount of energy at the beginning as at the end of a period of time. That prohibits almost everything you can think of from happening. A tiny fraction of all logical possibilities are not prohibited by that. And that makes this a very scientific and very powerful premise or proposition, according to Popper.
So to summarize Popper, he saw that the logical positivist answer to the demarcation problem was to say, for something to be a science, it has to ask questions of empirical value. Something that has an answer that you can measure out in the world. And then he added on to that, scientific theories must be empirical, and they also must be falsifiable. It must be possible for your theory to be proven wrong if its predictions don't pan out.
Let's go beyond Popper now and talk about some people who came after him and their thoughts on the demarcation problem. So we'll talk about Thomas Kuhn next. And he wrote this really influential book in 1962 called The Structure of Scientific Revolutions. In his view, Popper is getting some important things wrong. In particular, he thinks that Popper isn't really thinking about science as it's actually done in the real world. And he gives this really good example. So back in the mid-1800s, it was noticed that the orbit of Uranus, the planet Uranus, did not do exactly what Newtonian physics said it should do. So if you took the leading physical theory at the time for gravity and dynamics and stuff, and you work out what Uranus should do, the real planet was doing something a little bit different. And according to Popper, scientists should have looked at this and said, oh, Newtonian physics is falsified, and we should have all thrown it out and looked for a new theory. Of course, that's not what happened. By this point, Newtonian physics had been successful in so many different ways. The scientists were reluctant to do this. Instead, they looked for they looked to patch it up with new auxiliary hypotheses. And of course, what really happened is that they figured out that the reason Uranus was moving the way it was moving is because there's another planet they didn't know about out there. And we call it Neptune now. And in 1846, Urbain Le Verrier predicted that there would have to be a planet in the location with the mass of Neptune in order to explain Uranus's orbit. And in fact, astronomers looked for it and they quickly found it, thereby rescuing Newtonian physics. So what's the takeaway, according to Thomas Kuhn here? It's that science isn't really about taking a bunch of different theories and then slowly falsifying some of them, leaving a whole bunch of other competing theories standing the way that Popper imagined. Instead, what happens is scientists work in a given paradigm, like the paradigm of Newtonian gravity and dynamics, and you stick in that paradigm and you kind of answer, take those theories for granted and solve problems within the existing paradigm. And this goes on and on and on until the kind of problems faced by that paradigm get sufficiently severe that eventually people start offering competing paradigms that have different concepts in them, and not just like adding a new planet, but by like the way that Einstein's theory of gravity totally changed the way we thought about gravity, replacing wholesale Newtonian ideas. And when that happens, we call it a paradigm shift. So history, according to Kuhn, are alternating periods of normal science, and then these big punctuated moments of radical change called paradigm shifts.
So if you're a physicist who studies gravity, for example, doing quote-unquote normal science in the 19th century might have meant something like studying the motions of bodies, rolling them down planes, and comparing the results to Newton's laws, force equals mass times acceleration and stuff. And maybe even developing further ideas from it, things like torque and momentum and those things. But after Einstein's general relativity was published, normal science about gravity started to mean using field equations and talking about curved spacetime. Our framework for understanding what gravity is changed. So what it meant to do science about gravity also changed.
Right. I think framework's a good word there. Like, even the definitions of words like space, time, energy, all of these words had new meanings after Einstein. They literally meant different things than they had meant under Newton. Like the stuff that is taken for granted in Einstein's view of the world, there's just no place for in Newtonian physics. So Kuhn said the falsification criteria for science that Popper put forward doesn't really take into account how real world science takes place. So Kuhn offered a different solution to the demarcation problem. His criteria for something to be science is if it has a well-defined program of research, the practitioners of that program of research are concerned with the inadequacies that program might face at a given time, and thirdly, that program is making progress over time, so long as there's some inadequacies, right? As long as there's some inadequacies, like if you give it long enough, they're concerned about it and they start to overcome those inadequacies. The people who you're asking, are they doing science or not? They have to be making progress, either through normal science or through paradigm changes. It's important that whereas like Popper's definition of science or the solution to the demarcation problem really has to do with like epistemology and like just kind of a logical structure of science. Kuhn's isn't that way. His is a sociological distinction. He would say that the reason why astrology isn't science isn't because of some like deep down logical structure. It has to do instead with just the way people are behaving. Are people concerned with certain things? How do they respond to those problems? What do they do when their theories continue to have failures? Those are the questions, according to Kuhn, that make something science or make something pseudoscience.
So if a theory isn't improving with time, if its predictions aren't getting better, and if its practitioners are not concerned at all with where it fails, then it's not looking like science, according to Kuhn.
So moving on to a third figure, I'm going to talk about Imre Lakatos. In a lot of ways, Lakatos agrees with Popper. He thinks trivial verifications of a theory are not useful, and they don't help you determine that a theory is more likely to be true. There's always a huge amount of data out there, and if you cherry pick that data or select that data to support your theory, you'll almost always be able to do it. You can find any number of examples where people point to astrology predictions that panned out. That doesn't make astrology more likely to be science, okay? Or for those astrological theories to be more likely to be true. Instead, what he emphasizes are the instances where a theory predicts stunning, dramatic, or unexpected things to occur, okay? Predictions that aren't trivial, but are totally not the thing you would expect. So if I had an astrological theory and it said, tomorrow, Shalma, you are going to buy one lottery ticket and you're going to win the Powerball. And I only made this prediction once and whatever. It seems very, very unlikely. But then if that happened, that would be a very, successful scientific theory, it would seem. At least you would want to take this seriously. On the other hand, if I say, Shalma, you're going to have a good day tomorrow. That's what your horoscope says. That's not very stunning. It's not very, dramatic. It's not very unexpected. I would like to think it's not unexpected. So one of those sets of predictions, it looks like a sign of something being scientific, while the other looks like a sign of it being pseudoscientific.
So if a theory is trying to get you hooked by correctly making a bunch of nearly trivial predictions, maybe you shouldn't be so convinced that it's legit.
The other thing Lakatos said is that you could identify science by comparing different competing programs of research. And if scientists are kind of gravitating towards the one that is making the most progress, that is a sign of that program being science. When people stick to a program of research that isn't progressing, when another competing one is progressing, that is a sign that those people might be doing pseudoscience.
I'm curious how Darwin's evolution fits into all this, because it's again doesn't feel like an experiment, but it does feel scientific.
I think some philosophers who were worried about the demarcation problem did not consider Darwinian evolution to be a scientific theory, at least early in the 20th century. I think this was a mistake. and I think almost everybody agrees it was a mistake in hindsight, because with the discovery of DNA, you could extremely, precisely test Darwinian natural selection theories of evolution. And, they have been tested and they do extremely, extremely well. But like, let's say you're considering Darwinian ideas of evolution in like 1880 or something, you might think that somebody could approach it pseudoscientifically and just like cherry pick data to support it.
And maybe that goes to show, like, maybe if our science of psychology, science of the brain, science of people in general was a lot more advanced, and we actually would be able to test things like Freudian psychology, Yes.
So, I think a lot of these people would say that, you could do astrology in a scientific way. Okay. What you would find out is that there isn't a correlation between the, location of Mercury in the sky and human behavior, but you could measure that. And you could approach Freudian psychology in a scientific way. You could approach Marxist history in a scientific way, but the people who happened to advocate for that stuff at the time weren't. That's the thing that you can point to. All right. And then the last person we'll talk about today is Paul Thagard. Again, another philosopher of science, and he offers a different solution to the demarcation problem. And he says that a program of research is pseudoscience if and only if two things are true. First, it's less progressive than its alternatives over a long period of time and continues to face many unsolved problems. But also, two, its community of practitioners make little effort to solve those problems. According to Thagard, these pseudoscientific endeavors often involve selective behavior in the way that people treat confirmations of their theory versus disconfirmations. And this is like a very telltale sign of pseudoscience. And according to Thagard, like, again, it's something isn't fundamentally pseudoscientific or scientific. It's really about the way that people are interacting with those ideas. So he thinks if you go back far enough in history, you could find a time where astrology was a scientific pursuit. People were trying to, approach astrology scientifically. It doesn't mean it was a good scientific theory, but they were trying to do science. And then in the modern era, they're not anymore. So it's a history specific and sociologically specific definition that Thagard offers up to separate science and pseudoscience. In my experience, practicing scientists in the real world don't often wonder about or worry about what science is exactly, and they don't worry about or wonder about whether what the thing they're doing, if it's really science. They just take that for granted. But if you look around at the world more broadly, there are plenty of examples you'll find of people who are offering alternatives to science, and they're awfully presenting those alternatives, falsely in my view, as legitimate forms of scientific inquiry. Most of these kinds of pseudoscience, are really no worse than being a waste of time. So, for example, I do know some people who will read their horoscopes and whatever, and I think that's a total waste of their time and energy, but it's probably not any worse or more damaging than that. But there are other examples out there of pseudoscience that can be a lot more sinister and can be downright dangerous to individuals and to our society. And here I have in mind people who might be cherry-picking data in an effort to support different kind of conspiracy theories, anti-vaccine arguments or things like QAnon, for example. So to me, I think it's useful for us to think about what science really is and ponder this in as deep a way as we can in order to help inoculate ourselves against falling into these kinds of mental traps that human beings can sometimes be prone to, as well as to be prepared to help others that we might know who might be in danger of falling into these kinds of traps.
Why This Universe is brought to you by the University of Chicago Podcast Network. It's edited and produced by me, Shalma Wegsman, and my co-host is Dan Hooper, a professor of astrophysics at the University of Chicago and Fermilab. If you like our show and you want to support us even more, you can find us on Patreon. There you can access ad-free episodes of the show, as well as exclusive Ask Us Anything episodes where you get to ask Dan and I direct questions about physics or anything else. So if you are curious about that, you can find it at patreon.com/whythisuniverse. Thank you so much for listening and for your support.